Hello, so today we're going to look at how to solve matrix equations. And the first thing I want you to do as you watch this video is to pause the video and actually attempt this problem here. So I want you to find the inverse of matrix A. And then once you find the inverse of matrix A, hopefully the answer, right, the inverse of matrix A times matrix A should give you the identity matrix. So I want you to find the inverse of matrix A and then go ahead and actually check your work to see if I get the identity matrix when I multiply those two together. Restart the video once you have done that problem. So hopefully all of you were able to figure out that problem. And so again, you have to start off by finding the determinant, which in this case was 13, and you do that by multiplying across the main diagonal and subtracting that from the product of the upward diagonal there. So in this case it was -8 minus the -21, which gave us the 13. Then to find the A inverse, you multiply 1 over the determinant times that matrix, variation of the original matrix, right, where we flip, right, or as one of the other teachers likes to call it, do the switcheroo here of these two numbers and negate the other two numbers, so change the sign. And so as you see, that happened here. And as we distribute the 13, the 1 over 13, you end up with this as your inverse matrix. And as you see when we do A, this is matrix A here, matrix A times matrix A inverse, we end up getting the identity matrix. And you can see here's the work below if you want to follow along there. So next, before we move on, I want you to try one more problem here. And this problem that I want you to try is going to just be an Algebra 1 type problem, but I want you to show all the work here. So the problem will be here, so this is going to be problem number 2 I want you to try of the day. And it's a problem 3x plus 13 equals 22. And here, as you do that problem, I want you to make sure that you look at and focus on every little step and show every little step. So pause the video here for a moment and try that problem. You should all be done this problem, and here's what I wanted you to look at is, okay, so to get rid of that 13, right, because our goal is to isolate the x value. So here, you were going to subtract 13 from both sides. And that 2 was ugly, so I'll fix it there. But we subtract 13 from both sides. And what happens when you have 13 minus 13? Well, it becomes 0, and we don't write 0 in the equation. So we get 3x equals 9. Well, in this case, right, most of you know, divide by 3, and x, well, x would equal 3. But why is it just x? Well, 3 divided by 3, those just cancel. But they're not canceling. Something's happening there. When I divide 3 by 3, it is really giving me 1. And as you learned in Algebra 1 or pre-algebra, a 1 in front of a variable, you can just get rid of the 1, and it can just become x equals 3. Which is the answer you should have gotten. So now, what we're going to do is, this here, dividing by 3 to become 1, is how we're going to use the inverse. So let's scroll down. So here, so it's going off the page, there we go. So how is the inverse useful? So remember, as we did yesterday, or the last time we met, a matrix times its inverse is the identity matrix. This is important because the identity matrix is like multiplying regular numbers by 1. You get itself, or nothing changes. So here are the steps we can use to do some matrix-based equations, right, by using the inverse. So pause the video here and take a second to write these steps down so you can follow along. One thing I will note is this order is important over here. So this order is important. Make sure that it's A inverse times B. If you do the opposite, you will not always get the right answer. So now that you've had a chance to write the steps down, let's look at some problems. So the first problem here we're going to look at is this problem here, where we have a matrix A times a matrix X that is unknown equals some matrix B. So here this is matrix A, this is matrix B, and we have right here, this is that unknown matrix, right? The unknown matrix there, X. So the first thing that we're going to do is try to find A inverse. Well, to find A inverse, right, first we have to find the determinant. So the determinant of A becomes 15, right? 5 times 3, or 3 times 5, minus negative 7 times negative 2, so minus 14. So there, the problem was nice and easy. The determinant was 1. So we're trying to avoid fractions in this problem. So now, to find A inverse, is 1 over our determinant, which was 1. So 1 over 1 is just 1. And then we do our switch and negate. So 5, 2, 7, 3. And when we distribute the 1, or do scalar multiplication there, that 1 over 1 doesn't change what's inside the matrix, so there is A inverse. And as we move along, so now we have A inverse. So now, as if you have written this down in your steps, you'll see now that we have A inverse, we do A inverse on both sides. So we multiply both sides by A inverse. So 5, 2, 7, 3, that's A inverse, times the matrix A, which is 3, negative 2, negative 7, 5, times matrix X, because that's still there. And then on this side, again, we have A inverse, 5, 2, 7, 3, times matrix B. And matrix B, negative 2, 4, 3, negative 1. And so if we look, this was matrix. This is A inverse, this is A, this is A inverse, and this is matrix B. And so here, A inverse times A. Well, A inverse times A should give us the identity matrix. And if you want to double check my math, go ahead and do the matrix multiplication there to check that out. So the identity matrix times X is now equal to A inverse times B. And as we do that problem, we start row 1, column 1, and that is 5 times negative 2 plus 2 times 3. So there we would get negative 4. That's negative 10 plus 6. And we can keep going. Okay, row 1, column 2. So 20 minus 2, so 18. Row 2, column 1. Negative 14 plus 9, so 5. Negative 5. And row 2, column 2, 28 minus 3, so that gives us a 25 there. And at this point, okay, we have some identity matrix. Well, remember, what is an identity matrix times a matrix? It's just itself. So here, an identity matrix times X will just give me X. So here, X now equals negative 4, 18, negative 5, 25. And that should be our final answer. If we would like to check, what could we do? Well, we could plug that matrix back in here, multiply matrix A by matrix X, and see, do we end up with matrix B? Good. So now I want you to have one more problem here to practice with. And as you see, matrix A there looks pretty close to what matrix A did in the first problem. And I want you to try to do this problem on your own and check back on the video when you're done. Well, now you should be done with this problem. Let's look at how the answer comes out. So again, matrix A, the determinant. So we're trying to find the inverse, but the determinant is 1, and we do our switch and negate. And so here A inverse is 3, negative 2, negative 7, 5. when we multiply both sides by A inverse, we end up with this here, this equation. Then again, A inverse times A should give us the identity matrix times X. Over here we're just doing matrix multiplication of a 2 by 2, and here's the answer you should get there. And finally, when we're done with that, well, the identity matrix times X is just X with, and X is equal to a 2 by 2 matrix. So I hope that you have a little bit better understanding of, okay, why do we have this thing called the identity matrix? Why do we have this thing called the inverse matrix? And all that. But again, this still might be taking a lot of time or a sheet of paper, so now you have some time in class to finish working on your homework or begin working on your homework. And again, the more problems you do, the faster this will become and the more comfortable you will be at it.